Hi, this is Mrs. Villette, and in this video I will show you how to find the equation of a tangent line to a function at a particular place and the equation of a normal line. So we're going to do an example with x cubed at x equals 4, and to start we need to find the derivative function. So I need to find h prime of x. And our definition right now, the only technique we know, is to take the limit as h goes to 0 of f of x plus h, subtract f of x all over h. And for our particular function, which is the x cubed function, that means doing x plus h cubed, subtract x cubed all over h. I'm going to give myself a little scratch zone because I need to cube out x plus h, which is x plus h squared multiplied by x plus h. I know this first one to be x squared plus 2xh plus h squared, and then I'm going to multiply through by x plus h, which gives me x cubed plus, I'm going to multiply the x's first, 2x squared h plus xh squared. So that was multiplying the x through to everything. And now I'm going to multiply the h through to everything. Okay, and I get another x squared h, which I'll write right down here. I get an 2xh squared, and then I get an h cubed. And so when I combine my like terms, x cubed plus 3x squared h plus 3xh squared plus h cubed. So limit as h approaches 0. Hopefully you recognize that this x cubed and this x cubed are going to cancel. So all I'm really left with is 3x squared h plus 3xh squared plus h cubed all over h. If I were to try to directly substitute h right now, I would get a 0 over 0 form. But if I recognize that every single factor has an h, I can go ahead and cancel an h from everything, which would essentially reduce these factors by 1. And now I have limit as h goes to 0, 3x squared plus 3xh plus h squared. And if I directly substitute 0 for h, I just get 3x squared. Okay, we haven't actually found what we were asked to find, which was the equation of the tangent line at 4 and the equation of the normal line at 4. What we do have right now, though, is a function that will give us the slope at any particular point. So we had for h of x equals x squared, x cubed, my h prime of x was 3x squared. So this is my instantaneous rate of change. We're wanting to find a tangent line at 4. So my tangent line at x equals 4 is going to have slope given by h prime. So h prime of 4 is 3 times 4 squared, or 3 times 16, which is 48. And my h of 4 is 4 cubed, which is 64. So I have the point 4 comma 64, and then I have this 48, which is my slope. We use L of x for tangent line, so L of x would be 48 multiplied by x subtract 4 plus 64. And you could just leave it like that in point slope. And the normal line, if you have the tangent line, is really easy because all you do is take the opposite reciprocal slope, but keep that same point. So I'm going to check in Desmos now and graph the original function, its tangent line, and its normal line. So what we can see here is I've graphed my original function. So I've graphed my h of x equals x cubed. We had to zoom pretty far out so we can see the little bend here, but the x cubed function starts to grow pretty fast. I've got my tangent line. L of x is 48 times x subtract 4 plus 64. You can see that we're up here at the point 4 comma 64. That purple line, which is my tangent line, is actually covering up most of the function. Because the x cubed function is relatively straight, when we're getting further and further away from x equals 0, it does indeed look like a line, which is our idea of differentiable. And then we've got the green function here, my normal line, which does appear to be perpendicular to my tangent line. Again, we're using this square scale here in order to see that perpendicularity. So that is how you find the equation of a tangent line and a normal line. First, find the derivative, then find the slope where you want to find the slope at. So you're going to find your derivative. Then you're going to find slope. So just plug in C. Then you're going to find the point. And then you're just going to plug it all into point slope. And that's it.